Hello, my name is Richard Spindler and I'm a mathematics instructor. I've observed that many students work hard, some very hard, but I have also observed is that many students do not study effectively. I've created 3 videos for students to give them guidance on effective study. But from a big picture point of view, these videos are also about helping students learn how to learn. I hope you find them useful. So here's a list of the 3 videos. The first one, this one, is first about mindset and attitude, how you approach your coursework, as well as setting learning goals and thinking about higher levels of learning above just remembering or memorizing information. The second video tries to give you some techniques for how to retain the information and understand the information from your readings and your classes better, as well as using active learning to better understand that information. And the third video provides some specific techniques for recall of information. So let's first talk about mindset and attitude. So I have a question for you. Do you believe your success is limited by fixed ability or by how hard and how effectively you work? Your answer to this question is really important. Those with a fixed mindset think that their success is mainly based on ability, which doesn't change, while those with a growth mindset believe it is more to do with effort, how much effort, and how effectively you work at your work and at your problems. The problem with fixed mindset is the following. Suppose a student doesn't do well or doesn't succeed on a task. That student with fixed mindset might think, why should I try any more or harder since I just don't have the ability anyhow? Also, prior to a task, students with fixed mindset will fear failure because it might show they don't have ability. While a student with growth mindset who doesn't think it is about ability might learn from failure and say, well, okay, I didn't do well, so let's see what I didn't do well on and work on that, and put more effort into it and study more effectively. You and anyone else can move toward a growth mindset. Let me tell you a little story. I had an older student in a basic college algebra class, and she told me a little bit about herself. She had been in college as an 18 to 19-year-old undergraduate in a college algebra class and didn't do well in some other classes also. In math, she was afraid of it and didn't think she had the ability. And she also was involved in a lot of other activities and didn't focus on her studies. And I think she even eventually dropped out of college. Well, here she was, back in my college algebra class course 5 to 10 years later. And guess what? She got an A in the course. So now I have a question for you. Did she suddenly grow a math brain or acquire a math gene? No, she did not. She changed her mindset about the course and her studies. She developed a growth mindset. So let's go on to the next part about attitude. Are you motivated? By what? What are your learning goals? Is it just to memorize and get through the course? Are you curious about the course topics? Will you be persistent in your studying? Your answers to these questions are hugely important. Your motivation really affects how well you do. And there's good news. Based on the story I just gave you a minute ago, with support, you can change your mindset and attitude, improve your confidence, and succeed. The key to success is not simply the effort, although that's important, or focus, or resiliency, but it is the growth mindset that creates them. There are some inspiring stories about mindset and attitude. This first one on here is about a track star, and the other 2 are stories of students that succeeded after failing in mathematics. I encourage you to take a look at these videos. Here's some references about our discussion both in this video and in the other videos that are coming up. The book on mindset discusses that concept in more detail. And the second book is about attitude, motivation, and working hard. Let's talk about learning goals and higher level learning. First, I just want to describe to you different levels of learning. You probably have not seen this before, which is okay. Remembering. Many students focus on remembering, down at the bottom down here, So you are in a lecture or reading a book and you just try to memorize definitions, terms, procedures, dates, events, whatever the topic is. This is really just the very basic level of learning. Important, but it's just a start. There are other different cognitive tasks in learning that are important and it will actually help in the remembering. So the next one is understanding. Can you make sense of the concepts you are memorizing? Applying. Can you apply them in different ways than what you saw just in the lectures or in the book? Can you compare what you've learned to other concepts you've learned before or you know about already? Can you make judgments and justify your work? That's evaluating. Can you make new information or apply known information in new ways? We'd like you to start thinking about using the basic information and remembering task in higher level cognitives also. And let's just look at some examples. Let's take sports, in particular basketball. For remembering, proficiency of basic skills such as dribbling, passing, and shooting in basketball would be down there. Understanding, can you explain the mechanics of those skills? Why are those different passing and shooting skills effective in different situations? Can you explain those things? Applying, using those skills in different tactical scenarios on the court would be applying. There are all sorts of different configurations on the court during a game. Can you apply the passing, shooting and dribbling skills in a dynamic way? Analyzing, can you compare the different ways of shooting and passing, discussing their advantages and disadvantages? Evaluating, okay, you have all these different tactics for a game. Can you choose optimal tactics depending on the situation? Or on a bigger scale, choose a strategy for the game? And can you justify why you made those choices? Creating, can you combine all that you've learned below here to create a new tactic or strategy for a game? Ultimately, you have to start working with all of these tasks if you're going to be proficient. Now, in any single course, you probably won't do well in all of them, or even given much of an opportunity to try all of them. In a particular course, you might do well in applying, so in the middle here, but maybe not so well in evaluating. That's natural learning and it's okay. But the important part is that you should be striving to do all of these tasks and asking those kinds of questions. In fact, the act of trying them will help you learn at other levels, including remembering. Let's take my field, mathematics, for another example. Remembering might be memorizing algebraic procedures, formulas, definitions, or basic concepts. Understanding would be, can you explain why procedures work, for example. Applying would be, can you apply the concepts or procedures or definitions to problems besides those that you've exactly seen already, that you know exactly have seen in a lecture or something? Can you apply them to new types of problems? Analyzing, can you compare and contrast concepts and procedures? What's the same and different about them? Evaluating, given a novel problem that perhaps has multiple ways of solving or even multiple answers, can you choose an effective technique and justify your choice? For example, you could solve by graphing, or you could solve it maybe numerically just by trying numbers in a smart way, or you could solve it perhaps algebraically. And creating might be combining different known procedures that you already know about to create a new procedure for a new kind of problem, or maybe just coming up with new ideas in known procedures. For those watching this video that have math anxiety, you may feel like, I can't do all that. If so, then you are probably in a fixed mindset mode, because with support from students and instructors, time, practice, and a growth mindset, you and any student can do any of these. But I want to emphasize, it takes time, it takes patience, it takes giving yourself a chance and having support from others to help you do that. There are many examples of subject areas that use all these levels of learning. For example, history, there's a lot of memorizing, but in history, that's just the very beginning. There's a lot of this going on also in good history studying. I like to bird a lot. I started birding a long time ago, And if for an example with that, remembering in birding would be, just remembering the pictures and songs of birds. But understanding would be, say, explaining why a bird might look like that based on its evolution and habitat. For example, I remember certain birds have large beaks for their size, like finches, because they eat seeds in their habitat. Applying might be applying my knowledge about known birds to a new habitat. Analyzing could be comparing and contrasting the characteristics of different types of birds. Evaluating could be given a habitat, justifying the types of birds that I'd expect in that habitat. Creating might be hypothesizing a model or a theory of why a bird has different songs. So you can see there are all different ways of thinking about birds, and that's true of any subject area. Now notice that this is often based on first recalling things about birds, remembering, but that is just a start. So given all that, what are your learning goals? Do you just want to be down here at the bottom of this triangle, this pyramid, just remembering and memorizing? My question for you is, why bother remembering something if you aren't going to understand it and use it for some higher level purpose in a realistic setting? Hopefully you ultimately will use this for something. So when you start a course, think about your goals, and that might help motivate you some. Finally, the greater understanding you have of the topic at all different levels, the more effective your recall, and vice versa. They actually reinforce each other. The easier it is to recall these concepts, the better you'll be at other cognitive tasks. Conversely, the more you work on these tasks, the more you will practice remembering. Let's just give a couple examples. Let's go back to the sports example of basketball. To focus on tactics, some of the higher level learning, you want your dribbling, your lower level learning here, to be automatic. But in order to improve these dribbling skills, you need to practice them in a variety of different tactical situations. So they reinforce each other. That's true in mathematics also. Remembering terms and procedures in mathematics will help free up your short-term memory to more easily apply them in different situations. But by trying to apply them and use them in different situations, you are helping yourself remember them better. So they're not mutually exclusive. They support each other. And I could give similar examples both in history and birding. So what I'd like you to do now is pause this video, and without looking back at the video and the earlier slides, test your memory by trying to answer these questions. Again, without looking back. Okay, I hope you were able to try that. That is a technique that is forcing you to recall information, and we'll get more to that, more about those ideas in a future video. So your next video is, I've titled here, Learning and Storage Information, and it's really about how to understand and better store the information that you get when you're reading text, or maybe you're getting information from a lecture, and also the importance of active learning in your studying. Thank you very much for listening to this, and I hope it was useful.